In this video, we'll look at trigonometric limits. The next kind of limits we want to look at trying to compute and analyze, and we'll actually use our one-sided limits that we discussed previously, are trigonometric limits. And the main limit we're considering here is the limit of the form limit as x goes to 0 of sine of x over x. If you look at the graph of this function, the graph oscillates, but it will come up to meet around here on the axis. Now this function itself, sin x over x, is not defined at 0. But graphically, you look at the limit, and this here looks like that it should approach 1 as x goes to 0. It turns out that is, in fact, the case. This limit does equal 1, and this is a fact that we have and can use with respect to these kinds of limits. So how do we know that limit equals 1? There is a not too difficult proof of this. It involves a combination of the squeeze theorem and our one-sided limit rules. The idea goes something like this. Let's look at the right-hand limit alone. Look at just the limit from the right. So x is positive. We can think about that as being a positive angle that will now embed in a circle and see what happens. So if I draw a unit circle here, I can let x be an angle. So that angle is x there. And I can draw several different shapes here. I can draw a triangle like that. I think about the area of the circle sector contained by x, and the triangle up to this point here. We've got our green triangle here, we've got our blue sector that contains this part as well, and our orange triangle all the way up to here. The key point of this proof that you will see potentially in a workshop problem is that the area of the green triangle is less equal to the blue sector area, is less equal to the orange triangle area, because these shapes are all contained in each other. Right, the green triangle is inside the blue sector, inside the orange triangle. These areas all nest like this, and this should give you flashback to the squeeze theorem. If I have a function that I care about, bounded by two things that I know things about, I can look and see what happens. And it turns out setting up an equation for what this looks like in terms of the area of this triangle, what the area that is, what the area of the sector is, what the area of the orange triangle is, we can get that down with the squeeze theorem. Just think about this limit equaling 1. And then because this function here is even, because sine of x is odd and x is odd, the limit from the left is also 1. Therefore, both limits equal 1, and the whole thing equals 1. That'll be details of what you will see later, but at this point, we want to see what we can do with this limit once we have that it exists. How do we use this sort of limit? Well, the main idea that we're going to use this with is using it to simplify more complicated limits that involve trigonometric functions. And the key point is that if I take any u that's going to 0, the limit of sine of u over u will be 1. So as long as the thing inside the sine function and the thing on the bottom match, that limit goes to 1. So we're going to look into our expression, try to find things of the form sine u over u, or equivalently, u over sine of u, right? As long as things aren't 0, I can flip them over, and that's fine. And if I can find expressions of that form, I can separate them out. I know they go to 1, and I can see what happens with the rest of the expression. So we're looking for limits of the form sine of u over u as u goes to 0, or and separate those parts out to make them 1. Let's see an example of what this might look like in the context of a problem. So I want to find the limit x goes to 0 of sine of 4x over 3x. Now, what I don't see here is something that matches, right? Here I see a 4x, and here I see a 3x. If those two match, this would go to 1, and I'd be great. But they don't. So what can I do? Well, I can rewrite this as the limit x goes to 0 of sine of 4x over 4x, and then times of 4/3. Why does that work? Well, then these 4's would cancel, and this 3 would then slide in here to make this 3x. I have not changed my expression yet. I have just moved a constant around to get this to line up correctly. And using my limit laws, I can pull out the 4/3 since it's a constant. Limit x goes to 0 sine of 4x over 4x. And based on our limit rule, since these two things match, this limit goes to 1. So this answer here is 4/3. As a brief word of warning about these kinds of problems, we did not say that sine of x over x equals 1. That is not a true statement. If I plug in any number that I want to plug in, I can't plug in 0. I plug in any number, I will not get 1. What we said was that, but we have the limit as x goes to 0 of sine x over x equals 1. You only get the value 1 out of this when you are taking a limit as the input goes to 0. Then all of this works. If you're not taking a limit or you don't have it going to 0, this does not simplify to 1. There's a basic idea of these trig limits and what we can do to simplify them and how we can think about and manipulate these problems to solve out to simplify these limits when they involve things like sine x over x.